Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 1. We're on question number 49. So this question is asking us if you were to take the Taylor series expansion of e to the x and you truncate it somewhere, so you end up with a polynomial, an nth degree polynomial. The question is how many terms do you need, like what is n, if you want the error to be less than 10 to the negative 6. We know that the more terms we take, the smaller the error is going to be. So the question is, what's the smallest number of terms that we can take and still have an error of less than 10 to the negative 6 when we calculate the fifth root of e? Remember, so you have to remember that the error term, if you have a Taylor polynomial, then the error term at some point, call it x naught, which is defined as the actual value of the function at x naught minus the nth degree Taylor polynomial evaluated at x naught, is going to be, it's like the n plus first term of the expansion, the one that we truncated. So it's going to be the nth plus first derivative of f evaluated at c, and I'll say what c is in a second, divided by n plus 1 factorial times x naught to the n plus first power. Now c has to be, c is some number between 0, if this is an expansion around 0, and x naught. Okay, and that's all we know about c. So in our case, remember, so our error term, we're looking for the error term at e to the 1/5 power. So it's like x naught is 1/5 because our function is e to the x. So this is going to be the n plus first derivative of e to the x, which is just e to the x, evaluated at c, so it's going to be e to the c, over n plus 1 factorial, and then times x naught, which is 1/5, to the n plus first power. And we want this to be less than 10 to the negative 6. Okay, so the question is, what is the smallest value of n that will satisfy this inequality? Well, let's see. If we try to rewrite this a little bit, 1/5, that's the same thing as 2/10. So it'll help us to write 2/10 because then we have 2 to the n plus 1 over 10 to the n plus 1. And so if we try 10 to the 5th, this will give us like a 10 to the negative 6 here. So we'll be able to compare it easily to the 10 to the negative 6 there. And e to the c, well, c, the biggest that c can be is 1/5. And e is about 2.17. So 2.17 to the 1/5 power, that's definitely less than 2. So we know that this whole expression, we can, if we put a 2 here and leave everything else the same, then this whole expression is definitely going to be less than this. So now the question is, when is this going to be less than 10 to the negative 6? Well, let's try 5 for the middle option, because that'll give us 10 to the negative 6 there. So if for n equals 5, we get 10 to the negative 6 times 2 to the 5 plus 1 is 6, and then we have another power of 2 here, so that's going to be 2 to the 7th, which is 128. And in the denominator, we're going to have 6 factorial. Well, 6 factorial is 720. 128 over 720 is definitely less than 1. So yeah, this is going to be less than 10 to the negative 6. So 5 works, but that doesn't mean necessarily that it's the right answer, because maybe 4 also satisfies the inequality, in which case the answer could be 4. So let's check 4. If If we plug in 4 to this inequality, we'll get 2 to the n plus 1, so that's going to be 4 plus 2, which is 6. So 2 to the 6th all over 5 factorial, and then 10 to the 5th power. Okay, well 2 to the 6th, that's going to be 64, and 5 factorial, that's going to be 128. Well, 64, no, not 128, it's just 120. So 64 over 120, that's approximately 1/2. And we still have this 10 to the 5th down here. So the question is that less than 10 to the negative 6th? Well, it's 1/2. That's the same thing as 5/10. So that'll be about 5 times 10 to the negative 6th. So no, that's not going to work. So it looks like 5 is the smallest integer that will satisfy this inequality. So the answer is C.